Greetings and welcome. In this session, we will study the multi-pressure system, two-stage compression system with flash intercooling method. So here, this is a schematic of the two-stage compression system with flash intercooling. So here, this is a flash tank actually. And intercooling means what? Intercooling means here, if you see here in the pH diagram, this is a compressor 1 to 2. So this is a compressor 1 to 2. So after the compression, here first compression, this state of the vapor, that is superheated vapor, this state we bring to the saturated state. So that is why this amount of heat from the vapor is to be removed. So for that, the process is called as desuperheating. So for that, we have to cool that vapor. So that is why here this vapor line we are giving to the flash tank. Thus here intercooling of the refrigerant is taking place from the point number 2 to 3. So point number 2 to 3. So that is why the system is called as with intercooling, two-stage compression system with intercooling. Remaining part is here. You can take here, this is a cooler, that is a flash tank. So from the flash tank, this line is taken out, that is a vapor line, and that is given to the compressor 2. From the compressor 2, this is a line which is given to the condenser. From the condenser, here you can see 5 to 6 is a expansion taking place. This expansion line, after that, it is going to the liquid, this flash tank, and this line is continued from 6 to 7 through the another expansion valve, and then this 7 point is the entry of the evaporator. 7 to 1 is a evaporation process, that is a cooling process. Here cooling effect is obtained in the evaporator, and here the cycle is completed. So in this way, now you can see the points 1 to 2, that is a compression, 2 to 3, that is a intercooling, 3 to 4 compression in high pressure, 4 to 5 condensation, 5 to 6 expansion in upper envelope, that is in a second compressor envelope, 6 to 7, that is the expansion in a low pressure compressor envelope, and 7 to 1 is a evaporation in the evaporator. So in this way, here this is a schematic or construction of the two-stage compression system with intercooler. This is a pH diagram. From the pH diagram, we need all the points, values of the enthalpies. So these enthalpies we get on the chart when we solve the numerical. Point number 1, enthalpy H1, point number 2, enthalpy H2. In this way, all the points 3, 4 up to 7, all these enthalpies we get here at the scale. Now in this case, as 5, 6, 7, this is a complete, all these points are coming on the single line. That is why here enthalpy of point number 5, 6, 7 will be same. So this we will use in a numerical concept. Now we will go to the formulae which are required to solve the problem. That is analysis. Before that, we will see what is the difference actually, how this intercooling system is different from the earlier system, that is a flash gas removal. So for that purpose, if you see flash gas removal method, in that case you can see point number 7, point number 7 which is at the flash tank, this 6, 7 line. After that, here is a separation of that refrigerant into two parts, vapor and liquid, because here that next line which is passing to the evaporator, that is taken from the liquid side. So here the condition of vapor, which is condition of refrigerant which is passing to the expansion valve, that is a saturated liquid state. So that is why the 8-9 process is on the saturated line, is point 8 saturated liquid. But in case of this system intercooling, here if you see here the refrigerant, part of refrigerant which is going to the flash tank, and remaining refrigerant is taken from the same line, not from the flash chamber, because from the flash chamber if it is taken, then it is in liquid form, but this is in mixed form. That is why it is continued to the next expansion valve. That is why here 5 to 6 and 6 to 7, this complete line comes as a vertical line, isenthalpy process, that is constant enthalpy process. So this is what a difference between the flash removal method and intercooling method. Now we will go to the analysis. So in the analysis we have seen that for the compressor 1 normally we take M1 dot mass flow rate. For the compressor 2, means high pressure compressor, we take mass flow rate as a M2 dot. This is the capacity of the system, Q dot L is equal to M dot 1. This is the evaporation process we have seen in a pH diagram, point number 1 and 7. So enthalpy difference H1 minus H7. In the numerical, we are using this formula in the form of mass flow rate, because mass flow rate calculation for that, this formula we arrange in this way. And as in the numerical statement, here value is given in TR. That is why TR to kilowatt conversion, we use this multiplier. Now to find M2 dot, we have to use energy balance equation. Now energy balance equation, for that now we have to go again to the diagram, that is a schematic diagram. So here for the energy balance equation, you can take the portion across the flash chamber. This flash chamber, if you see, you will find here two lines which are entering to the flash chamber. This line from the condenser and this line from the compressor. And there is one output line which is coming out, and that is going to the compressor. So here will be equation what entering, amount of heat entering to the flash chamber, that is equal to amount of heat content leaving the flash chamber. So here for that, what we do, normally we take the product of respective mass flow rate and corresponding enthalpy of that line. So here will be first what, this is a line compressor from the compressor 1 that is going to this flash tank. So here this is a condition of vapor, that is point number 2. At the exit of compressor, this will be H2 enthalpy, and mass flow rate passing through this compressor, that is M1 dot. So product of M1 dot into H2, this will be heat content which is going or entering to the flash chamber. Addition to this, another heat content which is entering or adding to the flash chamber, that is coming from this line. Now this line is a 5 from the condenser. This is a mass flow rate M2 dot which is circulated in the upper envelope or in a second compressor. Out of M2 dot, here some refrigerant, means M1 dot, that refrigerant is passing in the lower envelope through the compressor 1. So here how much refrigerant is going to the flash chamber, that will be what, difference between this and this, means M2 dot minus M1 dot. So M2 dot minus M1 dot, this refrigerant content is going to the flash tank. So product of this difference, M2 dot minus M1 dot, multiplied by corresponding enthalpy. So point number 6 is here, that is entering point to the flash chamber. So here will be S6 multiplied by this difference. So summation of these two heat contents will be equal to line coming out content, means what, compressor 2 line, this. So this is a mass flow rate M2 dot multiplied by corresponding enthalpy H3. So this is what we see in the equation. So this is what we see in the equation as per discussed with the help of the diagram. We have M1 H2. This is a line of the coming from the compressor 1. This is a line coming from the condenser and entering to the flash chamber. So these two heat contents are heat content entering to the flash chamber, and heat content leaving the flash chamber is what, and which is going to the compressor 2, that is what, M2 dot into H3. So this equation, that is the energy balance equation, we use to find the mass flow rate 2. Mass flow rate 1 and mass flow rate 2. Once we get, then we can obtain the consumption of the compressor 1 and 2. Compressor 1 and 2, as per the earlier discussion, always we take across the compressor whatever enthalpy difference multiplied by its corresponding mass flow rate. So W1 dot is equal to M1 dot into enthalpy difference H2 minus H1. For the compressor 2, mass flow rate M2 dot and enthalpy difference, that is H4 minus H3, because here if you see in the diagram here, this 3 and 4 the compression process, so that is why 3 and 4 compression process means H4 minus H3 will be, so here will be H4 minus H3 difference. Both consumptions are in kilowatt. Summation of both consumptions of both compressor will be what total power required to run the system. Finally, coefficient of performance will be what? Q dot L, value is in given TR, conversion into kilowatt by using this multiplier, divided by this total power, that is W dot. So this is what COP. So in this way we have seen in this session the construction and working of the two-stage compression system with flash intercooling method. Also we discuss about the pH diagram and how to use the all enthalpies in the energy balance equation. Then analysis, in that we have seen the formula for the mass flow rate M1 dot, M2 dot, total power, and COP, that is coefficient of performance. So let us meet in the next video, that is numerical on the intercooling method.